Have you ever tried to figure out what's happening somewhere you can't even see just by looking at the clues? It kind of sounds like detective work, right? Well, it turns out it's the secret behind some of the most powerful tech we use every single day. So, let's pull back the curtain and take a look at this brilliant method for guessing the unseen. Okay, to really get to the heart of this, we're going to start with a simple puzzle. It seems almost ridiculously basic on the surface, but trust me, it perfectly captures the challenge of trying to know something you can't directly observe. I mean, think about it for a second. How can you be pretty sure about something that's totally hidden from you? It sounds impossible. But what if you had clues? So, picture this. You're in a room with no windows, and your friend walks in carrying a dripping umbrella. That umbrella, that's your only piece of data. It's the one and only thing you can actually see for yourself. But what you really want to know is what's going on outside. Is it sunny? Is it raining? The weather is the hidden information, the reality you can't see. But based on that one single clue, the umbrella, you can make a really, really good guess. And this is the exact kind of problem that a very clever statistical tool was designed to solve. So what is this special tool, this statistical detective for solving puzzles like our weather problem? It's a super powerful concept from the world of statistics, and it's called a hidden Markov model, or just HMM for short. You know, at its core, an HMM is just a system for dealing with a series of events over time. It's all built on this simple idea. There are hidden states, like the actual weather outside, and then there are observations that those states create, like your friend carrying an umbrella. The model's whole job is to use the power of probability to connect what you can see to what you can't. And here's the absolute key, the thing that makes an HMM work so well. It follows something called the Markov property. Now, that sounds complicated, but all it means is that to predict today's weather, the model only cares about yesterday's weather. It doesn't need to know about last week or last month, just the immediate past. And that, right there, simplifies things a lot. So, how does an HMM actually make these amazing deductions? Well, it's not magic, it's just a really clever recipe. And it all comes down to 3 key ingredients. Come on, let's pop the hood and see how this thing really works. Every high MM is built from 3 main parts. First up, you have the states. This is the hidden reality we're trying to figure out, like rainy or sunny. Second, you've got the observations. These are the visible clues that the states spit out, like umbrella or no umbrella. And finally, you have the engine that connects them all, the probabilities. This is what lets the model make its educated guesses. Let's make sure we've got this straight. On one side, we have the states, rainy or sunny. That's the true hidden reality. On the other side, we have the observations, seeing an umbrella or no umbrella. This is the visible proof. The entire game for an HMM is to work backwards from that evidence to figure out the most likely hidden state. Simple as that. So we've got our states and our observations, but right now, they're just lists of possibilities. It's that third ingredient, the probabilities, that really brings the whole model to life. They're the rules of the game, and they're what give it all its predictive power. Okay, so there are 2 main flavors of probability that the model uses. First, you've got transition probabilities. These just tell us the chance of moving from one state to another. For instance, if it's rainy today, what's the chance it's going to be rainy again tomorrow? In our example, it's 70%. Then we have emission probabilities. These tell us how likely a certain state is to produce a certain observation. So if it is a rainy day, what's the chance you'll see an umbrella? Here, it's a whopping 90%. By mashing these 2 types of probabilities together, the HMM can figure out the most likely story of what's been happening in secret over time. All right, so this is a pretty cool way to guess the weather, but what's that got to do with real life? Well, this is where it gets really, really interesting. You might be shocked to find out you've been interacting with hidden Markov models pretty much every single day. I'm serious. This elegant little mathematical tool is an absolute workhorse behind some of the most incredible technology we totally take for granted. It's really one of the fundamental building blocks of modern artificial intelligence. Think about it. When you talk to your phone, that's speech recognition, and it's powered by HMMs. The hidden state is the actual word you're trying to say, and the observation is the raw sound wave your phone hears. They're used in natural language processing to figure out if a word is a noun or a verb based on the words around it. And they're even used in bioinformatics to find hidden genes inside a long, long sequence of DNA. In every single case, an HMM is making an educated guess about a hidden reality based only on the visible data it gets.
Okay, so we've gone through the puzzle, the pieces, and the real-world applications. But what is the one single thing you should really walk away with about hidden Markov models?
It all just boils down to this one powerful idea. HMMs are built to model hidden states that create visible outputs over a period of time. That's it. That's the core concept. It's a formal, mathematical way of describing something you can't see just by looking at the trail of evidence it leaves behind. To put it as simply as possible, an HMM is a mathematical detective. It teaches a computer how to read the clues, the observations, to figure out the most likely story happening behind the scenes. From umbrellas and weather to sound waves and words, the principle is exactly the same. And that leaves us with a really fascinating thought, doesn't it? We've used this to understand our own speech, our DNA, and even financial markets. But what other hidden realities are out there just waiting for us to find the right clues to observe them? What else could we predict?